Alright, ladies and gentlemen, welcome back to the Shineponics Dev Vlogs. We've got some exciting stuff in store for you today. First order of business is to get this little guy working. You want to know the reality of hardware programming? Look at this. These cables, this thing, these cables. It took a dozen or so attempts at cables, this isn't even all the cables I tried, to find one cable that actually is capable of sending micro USB to USB type B data between the board and the computer. Anyone in the future that is trying to do this, heed my warning. Cables will be the end of you. You need a good USB cable, okay? They are not all the same. Okay, moving on to some code. And what I've got here is the Adafruit demo code for the unified sensor that does humidity and temperature. It's the environmental sensor that I have connected to the board along with the capacitive soil moisture sensor. Now if I reconnect this board, then you can see we start getting some data out of it. So that is live measuring. Now what I need to do is I need to modify this code so that we are also connecting to the analog soil moisture sensor. And I have a code snippet that does something similar. So let's find that and edit that together now. What we're looking at is some Wi-Fi logic as well as some pin reading logic. So we can skip through a lot of the clock things. This code will be needed to connect the IoT stuff, but for now, here we go. We want to grab that. So soil moisture is going to be set to be an output pin. That makes a lot of sense. We're reading it as an output. And we will steal some of this code here. We'll put our analog soil moisture reading. Now, of course, we're not talking about an LDR in this case. We are talking about soil moisture. Alright, looks like we compiled successfully, so let's flash that onto the board. So, awesome, it's read the board, it's connected. This is the board that we are talking about, the ESP8266 with Wi-Fi. So that's exactly what we're expecting to see, and we are writing the binaries of our compiled code onto that little chip now. Okay, so it looks like it's written, and if we go to our output here, we can see we are reading soil moisture. We are printing that as well as our humidity and our temperature now. And let's see, I'm going to dip it in my mug of coffee that I have here. Yes, we can see it goes down significantly. Alright, so these are the values that we're working with. Okay, I'm just going to record my raw reaction to this because I have been debugging code for over 3 hours. I have been bashing my head against the wall for hours trying to get this setup function working. So this stuff you've seen before, but this stuff up here is all about creating the correct configuration for encrypted web traffic. We've got quite a lot of code in this file now. And here is it working in action in all of its beauty. So every 5 seconds we can see a new log come in. So there should be one any second. There we go. So we start a connection. We see that we succeed on the connection. We read humidity, temperature, and soil moisture values. And then we send those to the server. And here is some data coming back from the server. And now what's really cool is if I go over to my web server here, I can see all of these requests coming in live, real time with soil moisture values. If I put my soil sensor in some water, we see some reduced values coming into the web server, which is super cool. I have here the solar battery pack that we saw in the previous episode. And what I have here is a really cute little solenoid. We're going to use this little lever to open up our water valve. Watch that little lever arm. Ba-ba! We have mechanical power. And so it turns out actually the solenoids are powered by 5 volts, so I don't necessarily need to use the powerful relay that we saw last episode. But you know, there's a chance this solenoid is not going to be powerful. We may need to upgrade it, we may need to power it through something else other than the board itself, because this board is only capable of putting 5 volts out. So if we need a larger solenoid with more power, we will have to go back to the relay, but this makes it a little bit easier to experiment with. So the next step, now that I am able to send data to my web server, is to be able to receive instructions from the web server and have 2 devices connected at once, so that the humidity sensor here can send information and the solenoid controller here can receive information to turn the solenoid on and off.